Hi, welcome to Aurora Math. Today I'm doing a series of videos on proportions. For this one, we can do it two ways. One way we could do it is we could just simply do cross multiplication. So if we did cross multiplication, we would do 48 times 9 equals 36x. 48 times 9 is equal to 432. Then we would take both sides and divide it by 36. And we would get that 12 is equal to x. And if you have a calculator, that works. But I would challenge you when you're looking at problems like this to notice that 9 goes into 36, and we can actually reduce this fraction down to 4 over 1. And if we reduce the fraction to 4 over 1, we could then multiply both sides by x and get 48 equals 4x. Then when we divide both sides by 4, we get 12 equals x, and suddenly we can do the problem without a calculator. And it seems like a simpler problem when we do it that way. And I appreciate a simpler problem. When we look at the second problem, we have, again, cross multiplying. And really when we're cross multiplying, we're doing what we did the second way in one step. We're multiplying both sides by 7 to clear this denominator. We're multiplying both sides by 35 to clear this denominator. When we multiply both sides by 7, the 7's cancel and we're left with 7x. When we multiply both sides by 35, we're clearing this denominator and we're left with 35 times 11. I like multiplying by 11. There's this little trick. When you multiply by 11, you separate the 3 and the 5. You add them up, the 3 plus 5 to get the 8. So that 7x is equal to 385. It's one of my favorite little tricks with multiplying by 11. Then we divide by 7, and x is going to equal 55. All right. One thing you can do with proportions is you might note that proportions are the same as equivalent fractions. So if we got from 7 to 35 by multiplying by 5, then we would have to get from 11 to x by multiplying by 5. They're equivalent fractions. So 11 times 5 is 55. That has to work. So that's another way you can do these proportions. All right, so I'm going to do a combination of what I did over here. I am going to reduce my fraction first. I am going to reduce this by taking a 3 out of the numerator and denominator and get that this is equal to 5/9. Now I'm going to notice that the numerator, 5, is equal to 5. That means that 6x has to equal 9. If the numerator is equal to the numerator, then the denominator has to equal the denominator. If I divide both by 6, then x is equal to, let's see, divide by 3 halves. Now, if you didn't want to reduce first, you just wanted to kind of cross multiply, you're like, I don't want to think first. So you just wanted to say 15 times 6x is equal to 5 times 27. Then you would have had 90x is equal to 135, and then you divide by 90. You still need to reduce this down to 3 halves. It's going to take a little bit longer. Let's see, I probably would have started with taking out a 5 from numerator and denominator, and 135 divided by 5, of course, is that 27 over 18, and then I would have taken a 9 to get to 3/2. So if you don't reduce early, you have to reduce later. And oftentimes reducing earlier is the easier time to reduce. So by not reducing earlier, you're not necessarily saving yourself any work, because eventually you're going to have to reduce this fraction down to 3/2. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.